All right, graphing quadratics in Algebra 2. I'm going to do these videos in 3 parts. So I'm going to do each different type in a little mini clips. So first we're going to start with standard form, but just to start it off, I will be using the parent function to graph these parabolas. So just a reminder that the parent function is just y equals x squared. So the parent function has a vertex, just at the origin, 0, 0, and the parent function has an a value of 1, and it follows this general pattern. It follows the pattern of over 1, up 1, over 2, up 4, over 3, up 9. So on the graph, the parent function looks like this. It has a vertex of 0, 0, and then it follows this pattern. I'd have to make this just a little bit smaller here. Over 1, up 1, reflected over there, over 2, up 4, and then over 3, up 9, and then also on this side. So it's a little bit hard to graph on here on the iPad with the stylus, but I'll do my best. So this is the general parent function pattern, and we're going to use this pattern idea to graph the rest of the parabolas. So when we change the a value, we change the shape of the parabola. When a is greater than 1, the parabola becomes more narrow looking, versus when a is less than 1 or greater than 0, so it's like a fraction, the parabola becomes wider. Now if we don't change anything besides the a value, if all we change is the a value, then the vertex stays the same and just it becomes more narrow or more wide depending on what the a value is. So we're going to use that idea to graph these parabolas. So when we have a different a value, we're going to use the same general pattern. 1, 2, 3, 1, 4, 9. This is just the x squared. 1 squared, 2 squared, 3 squared. And then if a, so this would be, we'd go over 1, up 1, over 2, up 4, over 3, up 9. Now, if a is at -2, that would change the shape of the parabola. Not only would it be more narrow, but since it's negative, it would also go down. So instead of over 1, up 1, it would go over 1, down 2. So what I'm doing to get that is I'm multiplying this 1 by -2. So 4 times -2 would be -8. So we'd go over 2, down 8, or over 3, down 18. So that's kind of how it would change. So I think it'll make more sense once you see an example graphing with the parent function. So you've seen parabolas before, so this is just a review here. Your leading coefficient, the a, when that's positive, it means that the parabola opens up. When your a value out front is negative, that means the parabola opens down. And then the bigger it is, when it's more than 1, greater than 1, the more narrow it is. When it's less than 1, it's wider, it's more wide, and we're comparing it to the parent function. So if a just equals 1, then it has the same width of the parent function. It's just kind of the standard width then. I like this maybe a little bigger. Okay, so standard form is this one, standard form. When we have y equals ax squared plus bx plus c. Notice you can't have a equal to 0 for standard form or for any parabola really, because then you would not have a quadratic equation. So standard form looks like this. And when we graph our parabola, we first are going to start by finding the axis of symmetry, and from there we find the vertex. And for standard form, the axis of symmetry is found by taking the opposite of the b coefficient, so negative b over 2 times the a. Then that gives you your axis of symmetry. And for a parabola is symmetric, and so the vertex lies somewhere on that axis of symmetry. And so you use the same equation to find the x value of the vertex. Once you find your x value of your vertex, you plug that in to find the y value. You plug in that x value that you get when you do negative b over 2a. Now whenever you're looking for the y-intercept of an equation, it's when x equals 0. So if you plugged in 0 into this standard form, you'd get 0 plus c. And so what your y-intercept for standard form is always your c value, always that constant that's at the end of the equation. So let's do a couple examples. I think that will be best to help you understand here. Just let me center this. Okay, so the first thing you'll need to do to graph this parabola in standard form is find the axis of symmetry. And again, we use that equation, x equals negative b over 2a. So for this particular example, that will be x equals negative 2 over 2 times 1. So we have a, b, c. So that's negative 2 divided by 2, which is negative 1. So my axis of symmetry is the vertical equation, x equals negative 1. So I'm going to throw that on here the best I can. X equals negative 1. Now to find the vertex, I know that it lies somewhere along this axis of symmetry. I just don't know where. So all of these points along the axis of symmetry have the same x-coordinate, and that x-coordinate is negative 1. So I plug in, go back to my original equation, and plug in negative 1 for x. So I will get y equals, it'll be negative 1 squared plus 2 times negative 1 minus 4. So negative 1 squared is 1. That'll be minus 2 minus 4. Then you have to work from left to right. So negative 1 minus 4 is negative 5. So my vertex is negative 1, negative 5. So I can graph that. 1, 2, 3, 4, 5. Negative 1, negative 5. Now I'm going to use my parent function. If I wanted to continue graphing this with a table, like a general table, I would have to pick x values here, like plug in x equals negative 2, and then plug that into my equation and solve for y. Then I'd have to pick x equals negative 3 and plug that into my equation and solve for y. So I'd end up doing the same amount of work here in orange over and over again, and that becomes really tedious. But because I know that parabolas all follow the same patterns, depending on the a value, I can use the pattern, the parent function pattern, to graph it. The pattern I use is I start with the parent function, which is 1, 2, 3, and the parent function goes over 1, up 1, because 1 squared is 1, over 2, up 4, 2 squared is 4, over 3, up 9, 3 squared is 9. So that's my parent function. Now this particular parabola has an a value of 1. A right here is 1. So 1 times my y column actually ends up staying the same, which means that this parabola has the same width of the parent function and it doesn't change. So the only thing that has changed is that this parabola has been shifted to the left one and down 5. Otherwise, it's the same width. So I'm going to zoom in here so that I can try to do a better job of graphing this. And I'm going to make my pen just a little smaller too. Okay, so I had my vertex was at 1, 2, 3, 4, negative 5. Then I have to go over 1, up 1. So I go start at the vertex, I go over 1, up 1. And then I'm going to reflect that over to the other side of the axis of symmetry. Then I go back to the vertex, over 2, up 4. 1, 2, 3, 4. And then reflect that over. And then I go back to the vertex again. I start at the vertex every time. My vertex is my new 0, 0. And then I go over 3, up 9. And then reflect that over. Oops, 1, 2, 3 right here. And then I can draw my parabola. So we always start back at the vertex every time. And this is just a pattern that I'm using. Whoops. Let's see here. Did not mean to open something new. Here we go. So this is just a pattern. 2, 4 is not actually a point on this parabola. Well, it is. That's a coincidence. But like 1, 1 is not a point on the parabola. 3, 9 is not a point on the parabola. This is just the pattern that I use to graph it. So let's look at another example. This one has a little better graph. This parabola opens down since my a value is negative. My a value is -2. That means that it's going to be more narrow as well. So not only does it open down this time, but it's also more narrow. I'm going to find my axis of symmetry again by using the formula -b over 2a. Well, let me write that far up here. -b over 2a. So that's going to be x equals, it's already a -4, so it's going to be actually 2 negatives there, -b over 2 times -2. That's going to be +4 over -4. I'm going to have an axis of symmetry of x equals -1 again. So my axis of symmetry is at -1. Then I'm going to use that axis of symmetry to find my vertex. I need to plug in -1 for x. I'm going to scroll down just a little bit. Get some more room here. So that's going to be y equals -2 times -1 squared minus 4 times -1 minus 3. Remember to follow the order of operations. So you need to square that first. So that's going to be -2 times 1. That's going to end up being +4 minus 3. -2 times 1 is -2. -2 plus 4 minus 3. That's going to be 2. 2 minus 3 is -1. So my vertex will be -1, -1. So I can graph that. Now my parent function pattern is going to be 1, 2, 3, over 1, up 1, over 2, up 4, over 3, up 9. That's my standard pattern for my parent function parabola. Now this one has changed a little bit because of the -2 as a. So a is -2. So I'm going to take -2, my y column times -2 in each of these times -2. And that will give me -2, -8, -18. Then I'm going to cross this out to remind me that this was my parent function. I'm going to graph these two. So instead of going over 1, up 1, I'm actually going to go over 1 and then down 2. Over 2, down 8. So that's how the -2 has changed this equation. I'm not plugging these values back into the equation. The only time I used the equation was to find the vertex. Now I'm just using the pattern to graph it. So I start back at my vertex and I go over 1, down 2. And then you can reflect that over. Then make sure to go back to your vertex, go over 2, down 8. Right here. And then reflect that over. Here we go. Over 3, down 18.